This video looks at similar triangles. Now, two triangles are said to be similar if they are the same shape. Now, angles that occupy corresponding positions are equal, the ratio of corresponding sides is equal, and we use two different symbols for similarity. It's either the three vertical lines or a little squiggly line. Okay, so one or the other. Now, note when we're looking at similarity, the way to think about it is that one is the enlargement of the other. Okay, so we're looking at the same shape, but not the same size, and that corresponding sides, the ratio of corresponding sides is equal, and the angles that occupy corresponding positions are equal. So let's look at three conditions for similar triangles. The first one is AAA. Now, AAA means all angles in corresponding positions are equal. So if you look at these two triangles here, this angle corresponds to that angle, and they're the same. Okay, change color. This angle corresponds to that angle, and they're equal. And then finally, this angle corresponds to that angle, and they are equal. So corresponding angles are equal, so they're called equiangular. Now, our second condition is side, 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 and in this case, all our sides are in the same ratio. Okay, so the key is you're looking at, so they're in the same ratio, and the ratio is called our scale factor. So if you look at these two triangles here, if we look at the corresponding sides, so this side and that side, and then we have this side and that side, and then finally these two sides. So it doesn't matter which way you put the ratios as long as they correspond. So if we start with our second triangle, if we go 6 over 3, okay, that has to equal, start at our second triangle, 4 over 2, which has to equal 2 over 1. Okay, so 6 over 3 equals 4 over 2, which is 2 over 1, which equals 2. So our scale factor is 2. That means our second triangle is twice as large as our first triangle. Or, if we wrote our ratios the other way, 3 over 6, 2 over 4, 1 over 2, our first triangle is half the size of our second triangle. Okay, so they're in the sides are in the same ratio. Now finally, our final condition is side angle side. Now it is really important that that angle is in between our two sides. Okay, so our two sides are going to be in the same ratio. So our corresponding sides are in the same ratio, and the included corresponding angles are equal. So the angle in between the two sides. So if you look at our examples here, we have two sides, and then the included angle, the angle in between those two sides. So are our sides in the same ratio? Well, we have 4 over 2, so our second triangle over our first triangle equals 2 over 1, which is 2. So in this case, our scale factor is 2 again, so our second triangle is twice the size of our first triangle, so it's enlarged. So let's look at some examples. Now, whenever you're doing these, do what I've done. I've written at the top of my page my conditions for similarity. So AAA, SSS, SAS. So you know what you're looking for. So the question says, decide whether the following pairs of triangles are similar and give the abbreviated reason. So if I look at part A, I'm seeing straight off two sides at an angle. So when I look at my conditions, I'm going to be aiming for SAS. Okay, so I'm going to actually write that here in part of my answer. That's what I'm going to be looking for. So I need to prove that the two sides are in the same ratio and my included angle is equal. Straight off, that angle's the same. Okay, so I can write angle CAB equals angle FDE, which is 20 degrees. Okay, so I've got one angle that's the same. Now let's look at our corresponding sides. So in this one, if I go 4 over my big triangle over my smaller triangle over 2 equals my smaller triangle, which would be 3 over 1.5. 4 divided by 2 is 2. 3 divided by 1.5 is 2. Okay, so my scale factor is 2. So here I can go triangle. Now write them in so that the vertices correspond. So what I mean by that, triangle CAB. So I've started off in this corner and I've gone along my 2 side first. So in this one, I'm going to start at that corner. I'm going to go along the corresponding side. So it's similar to triangle FDE. And my reason is SAS. I've got 2 sides that are in the same ratio and the included angle is equal. Now I look at the next one, I don't have any sides. So if I don't have any sides, I'm going to be hoping that I can prove that all my angles are equal. Okay, so when I look at these 2 triangles, and to make it easier, I'm going to label them. So I'm going to go A, B, C, and then D, E, F. Doesn't matter which way you label them, just label them. But by doing that, I can now work things out. So in my first one, I have these 2 angles are equal. So let's write that. So I have angle BAC equals angle DEF. And I also have the other angle here is also equal. So angle BCA equals angle FDE. Okay, that has to mean our third angle is equal because of the angle sum of a triangle. Okay, if my 2 angles are the same, so if I think about triangle, if I look at triangle ABC, the third angle has to be 180 minus whatever the dot is, minus whatever the cross is. Okay, because of the angle sum of a triangle. Okay, therefore I know that angle ABC has to equal angle EFD. Because of that angle sum of the triangle, I now have proven that my 3 angles are equal. So therefore, and I'm going to start with my cross, go to my dot, triangle CAB is similar to triangle DEF. And the reasoning is AAA. Now let's look at the next one. An electricity pole casts a shadow of 30 meters. So this is the pole here, and its shadow is 30 meters. At the same time, a 2 meter high stick, so my stick here is 2 meters, casts a 4.5 meter shadow. Find the height of the pole. So first of all, I need to prove that these triangles are similar. So we're going to assume the pole and stick are at right angles to the ground. So that means that angle there and that angle there are at right angles. I'm also going to label, so I'm going to go A, B, C, and we'll label that D. So angle A, B, C equals angle, oh I need another one, E there, E, D, C, which is 90 degrees. Okay, next, this angle here is common to both triangles. So angle ACB is common, okay? So it's equal to angle ECD in the other triangle. So same reason as part B before, it means that that final angle has to be equal. So therefore angle BAC C has to equal angle DEC because of angle sum of a triangle. So now I know that triangle BAC is similar to triangle DEC because of AAA. Now because of that, I can now use similar triangles to work out the height of my pole. So I'm going to let my height of my pole be x. So x over 2, so I've gone this, my pole over my stick, x over 2, has to equal the length of my full triangle. So that's going to be my BC. So that's going to be 30 over the length of my smaller one, which is 4. Times both sides by 2. So x is going to be 30 divided by 4 times by, and that is equal to 15. And it's going to be meters. So therefore, pole, I was going to say that'd be a really long stick. Pole is 15 meters long. Let's finish with a couple of proofs. So the first one, prove that triangles ABD and triangle BCD are similar. So I've got triangle ABD, which is this one here, and triangle BCD. So it's that triangle there. So I'm going to try and prove that they're similar. I'm given two sides and I'm given an angle. Okay, so thinking about, and as you can see, I've written my the rules that I can use. I'm going to try and do the SAS because I have two sides and I have an angle because I know that that angle's at right angles. So let's go with that. So angle BDA equals angle BDC, which is 90 degrees. That's given to us. Now I have to prove that my corresponding sides are in the same ratio. So now the trick here is to not think that the triangles fold back onto each other, sharing 12, because that 12 can't be the corresponding sides because they'd be the same. So what you have to think about in this one is turning the triangles around. So what I mean by that, we have ADB, where this is 12 and that's 8. And if I rotate my other triangle around, okay, so I'm rotating BDC 90 degrees in an anti-clockwise direction. Okay, so that means this is 18 and this is 12. Okay, so if we think about the sides, oh, and I better label it. So this is D, this is C, and this is B. So for it to be similar, my sides have to be in the same ratio. So that means CD over BD has to equal BD over AD. Okay, so let's work that out. 18 over 12 has to equal BD is 12 over 8. Well, 18 divided by 12 is 1.5. And 12 divided by 8 is also 1.5. So that equals 1.5. So therefore, triangle, and now I've got them in the same rotation by drawing them again. I can write them in the same order. So triangle BDA has to be similar to triangle CDB. And the reason is I've got two sides and the included angle. So it's SAS. Okay. My last one, prove that PRS, triangle PRS, so PRS is this big one, is similar to triangle PQT. So that's this one here. Okay, so that's what I'm trying to do. Now, the first thing I see when I look at these two triangles, and I'm going to remove those highlighting so I can work with this. The thing that I see is these parallel lines here. That's a key point. So we have to use our knowledge of angles and our transversal. So remembering alternate angles, corresponding angles, co-interior angles, you're going to use that knowledge in this one because those parallel lines are clicking in your head. Oh, okay, I can use my parallel lines. Firstly, though, we have this angle up here, P, which is common. So I can go angle QPT equals angle RPS because it's a common angle. It's shared by both triangles. Now I also know because of my parallel lines that these two angles have to be the same because they're corresponding. It's forming that F shape. So angle PQT equals angle PRS, and that's because they're corresponding. Or if you want to, you can use the code. Similarly, this angle here has to equal that angle there, again because it forms that F shape. Okay, they're corresponding, so you can see that F shape there. Okay, so angle PTQ equals angle PSR, same reason, corresponding. Or write your F. Okay, so therefore my two triangles are similar using AAA. Okay, so triangle PTQ is similar to triangle PSR, and the reason is AAA.